live. Hello everyone. Welcome to a Sunday 3-hour afternoon stream. At least it's afternoon here in Central Europe. And what do I do? This sweater is new, so I need to take some scissors to it. Where are the scissors? Here. Hey Johnny, look at that. I like that at Decathlon they leave a little piece of fabric in there. That's the same fabric. So you can cut it like that and get rid of this whole, I don't know, telefax. Same here. This is, this is, needs to be hand washed because this is like merino wool. Here we go. It's gone. Completely off topic. How are you all doing today? Hello Elephant. Hello Johnny. Hello AJB. Hey Dutch. Hey Johnny. Vibe coding, web page that can create 2-color plant labels. Cool. Hey Peter. You mean 2-color for 3D printing? Generating G-code or what? Good morning in Boulder, Colorado. How is it doing? I'm in Hessia here, so we had some elections, or the elections are still going on. I went voting today, but it's not very national wide. It's only like regional elections. Dzień dobry, Pioga. So more Polish viewers. We are only missing Kaspa and some other ones. Right. Today to drink we have Booster. America has arrived. Elephant. Oh, you have you are quite high altitude, Peter. Yeah, we are here in Europe. Also, it's a little bit colder today. I believe it's 10 degrees C and almost freezing at nights. So it might be actually tomorrow morning. There might be some frost. I hope no more snow. Please, no more snow. I don't want to get up early to be snow plowing again. It felt like the spring is there. It's not. Yeah, I'm a little bit late because I took a shower. I couldn't show you my greasy hair. Hey Sonic. Hey DJ Encore. The Shipu. What? Half a meter? The Shipu. I thought you were living in Zurich. Is it so cold right now in Zurich? Or now I doxed the Shipu. Damn it. So sorry. The Shipu, you missed the new tweezers last time. You can poke. Yeah. Please don't. Oh, you're in a hotel in the Alps. Nice. You heard it, they're horrible. Oh, you came back home from half a meter. I thought you came back home for half a meter. No, from home, like being outside, just you went inside. You came back home from the Alps. All right, what did you do in the Alps? Are you skiing by any chance? You never talked about being the sportive guy. Putting like backflips on a half pipe with the snowboard or something. Oh, for the spa? Yeah, I have the spa visit in May. going to Rhodos again, but it's more like relaxation and all-inclusive 5-star hotel with embezzling the pink LED font again. Après ski was you just went for the après ski. We should call it like it is, peeps. We should call it like it is. Oh, Fu. Hello, Fu. Thank you for the 400 pesos. 40,000 pesos. We put it in the embezzlement fund. Okay, let's put a new text on screen. Let's add. Let's add text font and create it here. How do you write embezzlement? Here. Here we go. Are you 40,000 cop? Here we go. It's a little bit, wait, it's a little bit too large, the text. Top donators. Let's do smaller background color now. Alignment top. Where is the outline? Yeah, here is outline. Outline size, color. Let's pick black. All right. Oh, here we go. Where is this? No, 69. Okay, let's continue with what is more now, SAK or to SAK. We have now ranking. We need like some 40,000 Colombian peso is more than it's 102. Johnny, thank you very much. That's a generous donation too. SAK here. Spezialeinheit Kommando. In German. SAK. Where is the size? Can't find the size of oh wait, there is no size. You just change the size like this. Yeah, all right. Top donate. This is silly goose. More outline. Let's do 10 and 10. Still not enough. Here. That's good. Okay, let's take that. Here we go. I will use the embezzlement fund. Look at that. I even purchased it at Netto with 5% off. Went just specifically to yesterday to Netto to get some more booster for the weekend stream. All right, let's write. You know what? I'm addicted to my new soldering iron. That's so cool, so nice to solder. There is how many cans do you get for 25? Is it 50? Oh, that's expensive. Look at that. We get booster sugar free for Oh, you have the 25 cents on top of that. I mean, it's included with the 25, so it's like 75 cents per can on top. So you pay an extra of nobody can count that so fast. All right. Yeah, so I pay what is it, 70 cent for half a liter here. And that taurine is also like a main ingredient, except for water. Austrian mountain water. What? Huh? I mean the ingredients should be almost the same. You have Zitronensäure, Kohlensäure, Taurin, Säureregulator, Natriumcitrat, Aroma, Süßungsmittel. Down the upstream, down what? Only the goodness and the good here with the aspartame. Is it aspartame? Yes. I heard aspartame isn't like carcinogenic. That was just an urban legend. Probably probably some big companies fighting each other. I love your liver. Do you think my liver will be busy with that? I mean, if that was like with some schnapps in it, then probably. Not sure. Or if it had sugar. Stevia, yeah, stevia is plant-based, whatever. But not everything what is plant-based is good for your body. So you never know. I mean, everything is carcinogenic at the right amount. YOLO, yes, foo. Yeah, we need some coca plants in there. I want the coca leaves, actual cocaine cola. Can we do? Oh yeah, let's do it. This is child-friendly afternoon stream, huh? Gemini. Describe your image. Okay, let's go, people. Let's go. Uh, make a can of cocaine cola. If I what there's probably the domain already. Cocaine cola. Oh no. Okay. Make it look like Coca Cola uh, with red and add a sub as a small slogan soul of Colombia. Sorry, this is inappropriate. I know. I who cocaine called it soul of Colombia. You approve that? Okay. Then we have the approval. Please make it nano banana too. Never heard of that model. Cocaine cola. It's a refreshing elixir. Wait. Original formula. Soul of Colombia. There it is. Oh, this is amazing. Cocaine cola. Estimate 1885. Love it. This is like. Oh, peeps. Oh, why is my. Oh, yeah, there is still probably. Established. What? Estimated. Established. Sorry. Yeah, demonetized. Probably. It came from Google, so it has to approve itself. How I put it on Discord if you like to have use that. I can have that. Here we go. I put it on Cocaine Cola here. Cocaine Cola. Pablo Escobar, like the Escobar phone. All right. I guess I will today on what do we have on our plate? Yeah, I'm quite addicted to using the new, but I have no use case right now. Nothing to solder, but the new soldering irons. If you missed the last stream, they are so good. Like the eighth one here with the display. I mean it's always like the right temperature, so it's pointless, but it looks nice, and it's a little bit too thick to work on in between like 0.6 millimeter gaps, but this one with the really tiny tips is perfect for that. We Envigado, you so what's the how do they feel like the people in the city? How do they feel about Pablo Escobar? It's not like, I mean, sometimes people are proud even though he was probably not a nice dude. He was like a super criminal, but he's also a legend. I mean, legends sometimes. There are people, oh yeah, he was a legend. He did good for the community. I don't know. Probably saying a lot of inappropriate things here because I don't know what I am talking about. But I'm just curious. I never went to South America, still on my bucket list. Oh, wait, it's Central America? Oh, shoot. It's right in this, below the center. It is south. Yeah, it is on the south. I'm bad. This is, oh no. I mean, I was in Costa Rica. Oh, then, nah, Colombia is South America, yeah. Colombia is huge! Latin America, yeah. Oh, yeah, Death and Blood. Yeah, alright. I'm sorry. It was inappropriate to assume that any people like from the city are thinking well of this criminal. Here we go. Yeah, Colombia is huge. How didn't I know? I mean, I looked at it so many times. I just probably forget. Here we go. Where's my embezzlement money fund? Here, it's only on the first page. Yeah, I need to copy that on the second page as well. Hey, 404. Huge. You know what? It's bigger than Germany, believe. How many square kilometers? It looks like Germany would fit into Colombia. Like Germany has some jagged part here on this where Czechia is. It's probably a similar size. Is it? Nah, Colombia looks bigger. It's wider. Looks like there's a huge area here. Iran. No, not opening the can of worms here. Like the war in Iran. Oh no, it's a special operation, is it? It's not a... Alright. Yeah, Venezuela. Yeah, but this is not a Mercator projection. This is actual like sizes here. I mean, don't need as walls anymore. Too many regulations on that. That's good. Yeah. Only special operations, extra operations, and they only take weeks. Don't cost money and doesn't cause the world economy to collapse. What the hell did you click on? 404. No, we're talking no politics today. Here we go. Here we are. I wanted to add some more vias because we have some major current. Oh, this is the final moral release candidate for the blade cluster. I mean, we talked about this last time. Yeah, that's better. Look at that. I can order that, but we have only ground pins on this side, this half of the connector. The connector has to be there, otherwise it physically doesn't fit. And I need to so this is ground, 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 and I have vias all over the place here because all the current that's coming through these pins or the current is coming from ground and going doing its job there and coming back all to these things, and we have almost 400 milliamps per pin here. They're rated higher, I guess, and we can check. That's interesting. Look at that. Whoop! We select that part and then we can check the current rating for that with the specs, with the bot specs. We have a resistance of 0.066 ohms, 2.24 amps, so it shouldn't get hot. Wait, what is that? This is Altium, or do you mean the board? The Ultra Cluster version 1.4. It should be 0.3. I mean, there's one thing I also want to get rid of these lines here for the crystal. I should copy the crystal. The board, it's the Ultra Cluster. Look at this. This is where it's going. 128 of those. Oh yeah, 404. This is foo! Nice, more money for the embezzlement fund. Let's thank you very much. I will use it for inappropriate uses here. More of cocaine cola coming. I will buy a lot of cocaine cola for that. Thank you very much. No, I'm not. I'm using the CH570 right now. That's why we need crystals. Look at how many crystals we have. Ah, no, so many crystals. But I want to make a quick version of the 595, CH595 at some point. For now, I need to push out that, push it out the. We have some here, some Bitcoin mine. No, not trying Bitcoin mine. I want 1 MCU per pixel. I have a ray tracer. Those don't have. This specific one doesn't. Counterbalance point. You mean counterbalance like mounting holes, or what kind of balance point? Yeah, we have two mounting points on top. We can. Yeah, I know. We have two slots. They're like 2 millimeters, I think. So they should be. It will be hanging. For now, it's hanging. They might be standing, but there will be a bracket which balances like that. It doesn't show on here because this is not completely model true. It's just a mock-up. So there is that's also why there is no hole at this corner, because if you look closely, wait, let me show you. not this. CH32. Yeah, show me a CH32 with that has there. This is also a RISC one, but the CH3200 whatevers, they don't have an internal multiplicator. Now we are ramping up with internal bit operations and multiplication and division, which should be accelerating things a magnitude. So they will be way faster, and we can't do floating points. We can only do floating point calculations with, oh yeah, by the way, there are CH this year, that the row controllers, they are all CH32303, and they have even an FPU. So we will have, in the end, we will have 2000 FPU MCUs and 65,536 little cores that can multiply at 100 megahertz, which is quite cool. Yeah, let me show you. Where is it? Blade base here. No, oh shoot, I misclicked. Not that. Yeah, that's just for, that's the schematic for this one here. Yeah, let me turn it here. So I 006, yeah, but it's still slower, isn't it? Is it also 13 cents? I don't know. Is it out yet? I have no clue. I'm out of the. This is now, we're working on that for 4 months. Yeah, so that's the issue. I didn't, for the per first 10,000 I didn't pay anything. So you have some? Oh, that's cool. Yeah. And these are now 13 cents a piece. So, and I will. Yeah, they usually, yeah, it's like that would bust my funds for that project. I calculated 13 cents per piece, which is $8,000 more or less. Was it 8,000? No. What did I calculate? 65? Yeah, something like that. So it's a lot. Yeah, you can see this is the PCB here. This is the PCB. The mounting holes are right about here, and there is already not much space in between. So, and here, look at that, where the line is, we have a polar grid here. This is, I don't think KiCad has that, huh? That's one of the features that I actually like. Look at that. If you place the next board here, we have like 1 millimeter apart here space, and the QFNs, I measured everything, even with the caliper, our test board here. We have some test board with the QFNs already on there. German song. Hey Dutchmaker. Wackelkontakt. Ich hob und Wackelkontakt. Never heard of that one. Sounds Bavarian though. Yeah, so we can't have a mounting point on this corner because there is like 1 millimeter space in between the boards. Not happening. In the center, there should be slightly more space for that, at least to clip in the board. We have to design and print it as well, but now we need to get this order out. I have an engineer checking my design if there are any blunders. I will place 2 boards first. Where is it? Document PCB here. 2 orders. So wait, did I moved them a little bit around. Yeah, here, this is, you know what? Yes, that's true. The microcontrollers, but the issue is in the manufacturing process, you have like an extra, like quite, I need to get more vias in here. Quite complicated process because you need to put the code on there. So that's one disadvantage of having that. Yeah, so I changed it so my solder mask is ending here, and I don't want the vias to be exposed, even though they're capped. I don't know how that would work. I just want every via to be underneath the solder mask. This is quite tight. Let me move that slightly. Here. Blue pill. That's one thing. I don't know. I seem to have to turn it off so when I drag the vias, it doesn't collide. I think I could fit in another via here. Need to be careful because there is not much space, and running the, yeah, we have this indicator here. This is too close. We can move that down. We have a lot of space here. The current can move there. And get that down. There's space here, I guess. That's a weird shape now. But I don't want this line. This needs to be slightly covered because that's like a strip line or transmission line or whatever you like to say. And now I need the ground on top of that. All right, that takes a while longer now because the board is so complex. I hope it refills, and then we check the last issues. Huh? Is it doing something? Yeah. Oh, here. So yeah, the screen. Please let me. Yeah, report polygons. That takes a while. All right. So that's one thing, and the other thing that I want to do today is I started to code the communication. Here's my test board. Yeah. Let me get the camera so you can see as well. Some more lights here. Good. Here we go. We should use one of our new power supplies here. Whoop. Yeah, so this test here, we are using this only to power the device, but we have now our new power supplies. Let's use one of those. And some cables. So this is female. Yeah. Female to female. We have this new power supply that will. I don't need soldering station. By the way, I just bought like 2 weeks ago headphones for swimming. They're conducting, like bone conduction speakers here, so you can have them. This is Bluetooth 6, and I don't submerge like I don't submerge a lot of my head while swimming. I'm not like completely submerged, so it still works with on the bike. So um, they sound cool, especially because your ears are free. Um, they're they're like working better when the contact is like really good in here. So you need like to either, if you have like a lot of hair like me and it doesn't make a lot of contact while you're, let's say, not underwater or whatever, um, they get loud enough. But then if there's like, right, when I'm swimming and I'm above water and I set the loudness so I can listen to it very well, then it works so well, works fine. But whenever submerged underwater, there is like a better transmission between those transducers and the bone, and then it gets really loud underwater, and this is like getting crazy loud. So uh, you should just try them. It's quite cool. I like that for audiobooks and for music as well. So they have like MP3. So because Bluetooth doesn't work underwater, of course, they this one has like, you can get them cheaper without internal storage. But I think $30 and $50 for this year with 8 gigs of storage. And yeah, I love it. I really don't want to swim without music or audiobooks anymore. Yeah, I don't know. Should try maybe. I like it. Not sure with bicycle if maybe you get a lot of noise from the wind, especially if you have like additional something that caught, yeah, that catches the wind even more. That might be noisy. So probably headphones with transparency mode are better for that, so you don't miss like any. It's probably not legal in Germany, I know, but with transparency mode might be better, because then you have not so much noises there. For swimming, it's the only option, because they don't recommend. I don't know. I mean, the Pixel Pro thingies here. I think they should be somewhat waterproof, so I could use them while swimming. But they certainly say no. At some point, the PSU. That's what's the name of the PSU? Alien Tech. Alien Tech power supply. It's really cool. That was recommended to me, and you can control it over USB even, and they're not DP100. Yeah, you can. It has good specs, and yeah. Okay, let's set the, before I turn it. How do we do voltage? Yeah, not 11 volts. We want 3 volts, 3.3. Current limit 900. VSET. Okay. Let me change the current limit so we don't do accidental. We need to get used to the Frisney, Fernier, yeah, that's power delivery. And we got like the power delivery 60 watts power delivery gun, whatever, also from AliExpress. And the cable as well that shows that shows the power that's using it. That's supposed to be pink. It's more pink on camera than in real life. Somehow, for some reason, I don't know. Probably. ThinkPad, I don't know. What are they? Yeah, they are probably. Okay, so this and here we don't need. Oh, we have extra power for the LEDs. Yeah, that's cool. Okay. This is this power, and we have a second power supply. Here it comes. Second power supply for. Whoop. Oh no. Yeah. Did it store? Yeah, the setting. It's also 3.3 volts. And that will be the LED power supply. So we're setting it up finally here. So let's do LED power supply. Blue. No way. Some more stuff. These cables are not bad. Much bigger. That's strange. How many square kilometers? Fu, did you check? Tell us the stats. 1.1 compared to. All right. Really? 3 times as big. Weird. So weird. I thought the Mercator project. We don't have. What? Okay. How do I? How do I measure? Let's see. Doxing myself. How do I measure? Is there like a tool to measure? Print. Measure distance from here. Oh, here we go. We have, okay, that's 630 kilometers across. Yeah, this is probably the Mercator projection. But when we zoom in, the projection should be gone. Okay, and then here, measured. No. Here. It's a total one. No, clear measurement. Okay, here we go. You can put the in true size. Yeah. Let me measure first. Okay. Measure distance. Here we go. Yeah, that's twice as wide. Yeah, all right. Sorry about that. Yeah, that makes sense. That's Germany's quarter the size. Oh yeah, I know that. I mean, with Africa, the Mercator projection is quite unfavorable to specifically this region. But when you zoom in and then you have like the projection is basically gone because you have like the right scale here. So this is the look at that how every other continent fits into Africa. That's cool. Yeah. All right. Yeah, Colombia is huge. We should put Germany. Oh wait, I'm not even sharing my screen. Sorry. Yeah, that was the measurement. Germany, you have like we measured Germany to be 600 across, and there is this measurement tool. Let me show you again. Clear measurement here, clear measurement, and you can measure basically measure distance, and then you get this 1.5 thousand kilometers. Yeah, it's 4 times as big than compared to Germany. And what you were the true size is here. This thing here. This is the actual size of Africa. Look, like Algiers is like. Can I drag Germany? No. True size of Colombia. Here we go. Here we go. Colombia is as big as as Europe. Can I rotate it? Colombia has some islands. Looks like there are some islands. Yeah, I mean that's obvious. Here we go. Colombia is as big as France and UK combined. As big as complete Eastern Europe. Turkey is quite big. Saudi Arabia, Egypt, Australia. Yeah, Australia is big. It's a continent. And how about Japan? Mongolia. Yeah, comparable to Mongolia. Say. But Russia looks oversized. The projection is so crazy. Especially up there. Greenland isn't as big. Well, I mean, Greenland's still as big as Colombia here. Look at that. Greenland and Colombia. It matters where you drag it. If you rotate it, it's probably same area. And Antarctica, division by 0. Colombia is as big as the whole world. Look at that, division by 0. Boom. No. This is here. Colombia, what are you doing? No. Alright, let's concentrate on our work here. What do we want to do? Oh, wait. Yeah, fool. Look at that. Messed up. But we have only three violations. One is this here, so that should be easy. Yeah, we just moved that. That's, but I want it straight actually. So let's move it like that. Then this distance. So let's move it away a little. It should be alright. I mean, we can even more space. Was it that one? Oh, this one. I switched for this project because Altium is sponsoring the fund for this humongous project. All right, I guess this should be right now. Store it and push it. More ground. For now, I might be doing more with Altium in parallel because I mean I run out of for now. We have an agreement for one sponsorship, which will be, you know what? I can move this one because that clearance is the same, so that's all right. The sponsorship is for one project right now. I might want to use it because I like the impedance stuff, the impedance based routing. How much as as they pay me for. So $15,000 are the cost for the parts alone, what's estimated right now. So they pay that, and I would never pay that out of my pocket. So yeah, I'm taking the sponsorship. It's a thing. I mean, it took me probably 1 year, and I took basically something on top of that. Now, now that this project takes for so long because I needed to get used to the to Altium, and then planning took a long time. Everything. Um, I like stuff about Altium, especially if you want like to have like not like I don't know, making 2-layer badges, but if you want like to have good signal integrity and everything, the tools are quite cool. So we'll keep it. Yeah, report. I think we are done after this. There are online DRC rules checks. So, but with this the board this size, GTA 6, we will run GTA 7 on that. Is GTA 6 out yet? All right, I guess let's start it now. How do we start it? Oh shit, I turned it off. No, that's setting. $20.35, but it is a nice meme. Come, give me more that memes. Oh, here we go. Yeah, the LEDs are turned on, but I need also to, yeah, see, we go. Power supply. I have now code. So this one, we probably need to make some. Look at that desk here. Soldering stations. And oh yeah, these were the pouches for. These are the pouches for the power supplies, and you can fit like 3 of those power supplies in one of those pouches. We need to put an oscilloscope on here because I'm now sending illegal cable USB A to USB A. You mean that one? Is it illegal? I don't know. They have like the communication port, which you can control it from. Yeah, communication port that you which you use to control it uses USB A to USB A. I thought it was like some 5-volt power output, but it isn't. Spec compliant. Yeah, all right. Compliant. They don't output a lot of power on that port. Alright, let's clean up a little. What is this? We also don't need that. We need, where's my linky for? I'm missing one linky. The linky to program. Here it is. Yeah, there's nothing spec compliant on my channel. Oh no, I pulled off the debugging cable from that. Now I don't know which one is what. Outer one is ground, okay. This should be ground, and these two. or hopefully the ones we are talking to. Okay, where is the... Here. That's what I hate about USB cables. They're dragging my stuff down. Ah! Hate it. You need to put all the power supplies on the... all the power supplies on the table. And this is what I use instead. Clamps. Alright, here we go. So, let me clean it up. From the ceiling? Yeah, it should be that. Not here anymore. Yeah, let's move that. This is... Ouch! You know what happens? When I take this one and plug it in here, I poke myself with the very sharp tip of that. So I should move it like around or something. There we go. Oh, someone gets dizzy who watches that stream on 3D glasses. Two links, because one link is set to CH70 whatever. The one, no, one wire and two wire debug protocol. Apparently it makes a difference, and you need to press the button that's in the case to switch it. I don't know, or you can probably do it in software in some way or form. Why are there more tips? This is how I handle my tips. Oh, there is more cables. I should clean that up. Look at it. This is an PC. I initially wanted to use one big PCB with 1024 MCUs, but JC wasn't able to handle that uploading, so I needed to split it in half, and now using smaller board. Oh yeah, that tipped over. This is my new... You don't need to excuse yourself, just join and enjoy. There is no need like to be here on time. I'm not either, so that's alright. You know what? Why do I even... Yeah, they came in these cases. Yeah. The streams, for whoever didn't know, the streams are voluntary. It's just for your entertainment. If you hate what I'm doing, you don't need to stay. You don't need to be on time. There is no pressure of doing anything here. Where's... Oh, here. Here we go. I need this. Yeah, this is here. The scope. All right. Meanwhile, all DRC checks cleared. I will check it in. Save to server. More better grounds. Version control is one part of that, which is like grounds. Here we go. Whoop. Cop. What was cop again? Cop. On copper. Copper or copper. Interesting. Chip on board. You know what's weird? Why does it say Ooh. 0.002 amps? I don't believe that. Oh, that's weird. It's switching. Yeah, that's somewhat switching. The power supply. I mean, they're running from the same power supply. Let me switch to another power supply here. That one gets weird. Oh, I shouldn't do it. I shouldn't do it. We have some leakage current. Oh no. Two different power supplies. Not non-isolated. Oh, here we go. Uh-oh. Something's not working right. The two grounds. Okay, let me start one first. Current control. It's weird. Maybe you can put them in parallel. Okay, let me disconnect this one. Twelve. Oh wait, this is the one for, wait, yeah, I have a current limit. Yeah, sorry, that's my fault. I set a really low current limit. Yeah, we are now at 200 milliamps. Oh, look at that, the right, we have some current leaking there. Let's set the... Oh shit, yeah, here we go. Okay, so now we see with the LEDs are drawing 30 milliamps. That sounds about right, because we have a current limit to one about... Yeah, that's alright. Then 32... Oh, that's lower than expected. So I have like 32 MCUs plus that one that's 33 MCUs, and the expected current would be 340 milliamps max. So actually I am in the clear with my estimates for... We have plenty of headroom with the estimates. Alright, yeah, the current limit was too low for that one. Sorry, I was conservative. That's cool. So if we run it at... I mean, it's not calculating a lot right now. If we are running it like that, you can calculate, let's... that's... What do we have? 3.3, and it's right about 300 milliamps. 300 milliamps. Yes, if we do lower voltage on the LEDs, then we draw a lower current. 300 milliamps, and that's times 32 times 64. No, it's not. They're not concurrently on, but it's always phasing, like red and green. I know red and blue are basically in the sum of red and blue is 1. Just inverted. Red and blue are inverted, and then okay, so we have 614 amps in total times 3.3 volts, 2 kilowatts only. Oh, interesting. We are below the spec of our power supply now. Oh, let me check if I got my money back, because I got the power supply way cheaper. Again, can we even open it now? Because the last time we opened it and I had to send it back because it was overpriced. It was the last one from Europe. Yes, I got the money back from Galaxus. Galaxus is a good company if you want to try things. I mean, I'm feeling bad because I'm ordering at Galaxus, like I had to send back one screen that I didn't like, but I kept this one. I got this is an HDR. I use that for HDR editing because my bank died after 5 years. My bank did a bank. Yeah, so from the last 3 things that I ordered at Galaxus, I sent back 2, which is not great. I don't feel good about this. But really, they did only like reselling. I think that was like a different seller, which overpriced the PSU because now we got it for $400 instead of 700. Here it is. Let's open it finally. This one we will keep. Thank you. Yeah, bank. Thank you, made bank. Second unbox of the same thing. Crotch can. Here we go. Yeah, because some people didn't see that one yet. 404. You missed that stream. I mean, everything, we just repeat everything for 404. Here we go. This is the issue that I want to address today. That we need to. Oh, this beautiful chonker. That's constant 3 kilowatt output. Look at the spec. Look at this. Corsair. They are solving my issues. Do you see that? See that value? Oh no, now you have my serial number. Yeah. Alright, here we go. You see that? 250 amps. We need to step that down. We need 600 amps of 3.3 volts. So we are in the fine, even with. Yeah, this is you can start a car. You're right. What's this? Oh, look at that goodness. You can see there in there. There are quite serious coils and coppers in there, and caps as well. Is there a warranty void sticker? Yeah, here. This is the warranty void sticker. How is this switch here switching 3 kilowatts? Are you kidding me? That doesn't feel like a 3 kilowatt switch. Crazy thing. And we have like a complete mine worth of copper in there. So this is yeah, this is by the way, this is the cable that you get with that for 3 kilowatts. You just need the white contacts, and we need to design a PSU. That's one thing that we could actually do. We picked voice echo. What are you talking about? What happened? Are we sending? No, it's not. It's not sending desktop audio. No. Yeah. Are you watching in 2 streams? Are you look at look at that copper. Look at that copper here. This is the copper that we got with that. No, what? Yeah, but you can't get 600 amps through those lines. Are you crazy? It looks tired. And yeah, how do I mean, if I connect that, yeah, that you have just one side completely with connectors. I'm curious about how it looks inside. I mean, there must be like, I don't know. It's so crazy. Okay. We have 3.3 volts. We can get 25 amps. A picture link you sent me? Oh yeah, the one before. Yeah, a few weeks ago. This is full bridge rectifier. Yeah, there's probably just full bridge rectifier in there. This is the connectors that we got. They are like tiny. They needed to take like this. Look at that, 12 volts. That's PCI Express, but how do I don't get like, this is not, I don't get all the current from this, do I? What kind of 600 watts? This is 600 watt power. It says like that. Look at that cable. What? Yeah, that's watts, but we have plenty of those. We have 4 of those. 6 times 4, it's 2.4 kilowatts. That should be enough. We just need to connect those cables and we are in the good. Double check seating. What's seating? What? Do you mean? What? What's with my seating? Oh. Oh yeah, you mean because they will basically melt if they're not sitting in well. But what happened to the graphics card? Like whoa, here we go. All right. Yeah, no, that we have a audible click in there. Look at that. This is crazy. But this is not, I mean, that's only 2.4 kilowatts. Then we need some more from that. And these are 600 watts. Ugh. More! Good old fire hazards, yeah. I need to bring my CO2 extinguisher from the basement. We didn't try those cables before, but they weigh substantially. Let me get a scale, okay? So we know how much that is. Because this is like one of those cables weighs like, I don't know. Feels substantial. I have a scale here somewhere. I hope I have it here. What do you mean, why do I need a PSU? I need to power it somehow, like my super mega IMBA cluster. Oh, maybe we should call it IMBA cluster, like it's imbalance. Here we go. This scale, I believe, isn't good enough for 151 grams is that cable. So it's 151 grams for where is it, mode here for the Americans here. In Boulder, Colorado, it's 5.3 ounces. What is this? Carat? 70. I think that's the measurement unit that we should use in carats. That's 757 carats of pure copper. But this cable's worth. Oh, what do we have? Plenty of measurement. Yeah, they are substantial, and this whole PSU is. I guess it's like grams. That's cool. Look at that. That looks like a beautiful girl with nice and thick hair, like that. Nice, long, black, thick hair. And that's not enough. We need more. A resub! Hey Andy, thank you for the resub! What? Oh no. Dreadlocks gallons per bald eagle. Not. We have some nice people here from US, but just to get a sense of scale, how many ounces that might be. If you get used to those things from. Oh, this is cool. This is so hefty. It's so weird. This will pull off basic. I can imagine this power supply when it's somehow like the cable, it pulls off everything, and then several screens monitors everything that I own just off the table because of its own weight. Nice. Let's try this thick chunker here. Substantial, but it's only like 2.5. Is it 1.5 AVG? No, square millimeters. This is only. We checked it last time. Was it 1.5? So it's not like a lot. It's like on position. Yeah, I can plug it in. Yeah, 1.5 square millimeters. I can't plug this in any socket here because of the wiring from this. All this wiring up here, upstairs, except maybe for the. Yeah. There is one out socket that I placed, and the wiring is from the 80s, so. Okay, we don't need the SATA cables, but the SATA? How do we power? We need more, 600 watts more. We probably will use something like that. Crazy thing here. Love it. Oh! That's how it happens. The echo happened because I placed the heavy cables on my keyboard. Uh-oh. Sorry. Is there still an echo? I just controlled my OBS studio with the heavy cables on my keyboard. All right, peeps. No echo. Okay. Thank you. So let's put it back. The Pandora's box. Let's put it back in there. The hefty thing. Oh, yeah. I get serious muscle here from lifting that heavy thing. And you know, I got it for $400, which is quite cool because the retail price in the US is marketed for $600 US dollars. Yeah. So we got that figured out. That was like another headache that I had. The only thing that we now need is to figure out how to convert it from 12 to 3.3, maybe 2.8 respectively, because we have different power lines. Oh yeah, we can talk about that. My mouth is aching already from the talk, but here we go. I show you the levels here. So lowest level is the little MCU. It has a separate power supply for 5. Hey Terran, foo, more embezzlement fund. Nice, thank you very much. Foo, we will embezzle even more. I will have some nice spa of that 8,000 cops. Here we go. Nice, here we go. Embezzlement fund top donator. Foo. Wait, is this many? That is not enough use there. Sorry, I need to respect your name choices here. Here we go. More. It grows with every cop. All right, so we have a separate voltage for the LED, which is all right. The only thing is, if we can draw it from, I think blue needs at least 2.6 volts. Yeah, the rating for 5 volts is only, I think, like 50 amps or something. What's the rating on the 5 volts? 25 amps, yeah. I guess I could mix it a little, but I will just start with the 12 volts because that's a safe bet. And if you do 12 volts, you need thinner wires. Yeah, only 25 amps. Yeah, 5 volts, you need like thicker, more amps, thicker wires, everything. Consider the bench around the Cray one and base it all power supplies. Yeah, that's an okay. Let me sketch out the power supply how I imagine we can do it right now, because we need plenty of PSUs. Like we can calculate some of that right now. I thought we can save a little bit on power on the LEDs. It doesn't look like the LEDs are drawing a lot though. It's like 1/10 of what the MCUs are doing, but we could lower the voltage. The issue is right now I would need to decide on what voltage I want to run the LEDs, because then I can't go with 1K resistors here anymore. If I get like higher voltage, we are basically losing any extra current on the as infrared heat on the resistors here. The problem is, if I go like close to the forward voltage of the blue LED, which is 2.6 volts, 15k resistor. You know, we want it to be bright. We want it to be like this here. This only with this brightness, which is 1 milliamp roundabout per channel. We are able to achieve 70,000 lumens, and we want that. Resist torrent. What? Yeah. If we go as low as, let's say, 2.6 volts, then this should be 0 ohms, and this should be still like 200 or 300 ohms. So we need to be very specific on the resistors when we do that. Otherwise, if we put like a resistor on here that's very current limited, if it's like 2.6 volts, it's very dim then. So I will just, yeah, quite exponential. Yeah, I will try to keep it, right? I will try to keep it like above 3 volts and leave the 1k resistors for now. If I see it doesn't work out well, we can, on the next batch that I order, we can place different resistors there. But currently the brightness differences we can basically manage to control with the PWM. The specs of my PC are not great. Why do you ask of my PC? Because of what? The RAM is, yeah, 128 gigs of RAM. No, it's not. It's quite old now. Usually I only switch my PC once I own a RTX 3060 with 12 gigs, I believe. Or is it 6 or 12? What is that? Yeah, it is. Oh, Terran, you have a nice you have a nice stash there. A RAM is gold. CPU is some Core i7 8 core thing with no hyperthreading, I believe. Yeah, here is i7 970K. Yeah, that's not like very substantial. 8 core, yes. The issue is more rich. What? Huh? Why? This PC is 5 years old already or something. I don't know. 5? When did I build it? Yeah, I built it more or less 5 years ago. The RAM was expensive there. I know I paid like $600 for RAM alone. Oh, you recently... What? Oh, all right. The issue is it wouldn't matter because okay, sometimes you lose, sometimes you win. I know that I switched. You know what happened last time? I was lucky with when I built this one. There was currently the I think there was the Bitcoin bubble right now, and I got the 3060. I was lucky because I got it like I think I had an alarm with Geizhals or whatever. I got it for $500, 515 or something like that, and yeah, reasonable price. And I had the 180 before, RTX 180 or something. No, 160. So the old one even sold for $350 or something. So I had like a really old card, and it almost paid for my several generations newer card. I think the one I got at least the same price for the RTX 160 that I paid when it was new. So I know I think that was the case. And the only thing, I mean, the RAM, I know it was a lot that because I don't I this is the first time I have an SSD as the main drive in the PC, and I didn't want to. Oh, Fu is going full AI. Good for you. You dude are rich there if you can get Tesla stuff. Prefer laptops. Um, yeah, so basically I didn't want to. I don't have a swap file on. I don't want to. I don't know, to destroy my SSDs at this point. I wasn't like experienced enough. If the SSDs will wear out or anything, if I use a swap file, so that's why currently it shows it uses 105 gigabytes of RAM, but it's not like it's using. It doesn't use you see like 40 gigs are used for actual applications and everything else is cache, and this much is just on standby. All right. Also welcome on Twitch. All right. Yeah, so that's that computer. The only issue that I have with this computer, I mean, um, I would I had an AMD before, and I had like random crashes. That was the issue why I bought and made went to Intel back, because I had like random reboots while editing. That was horrible. You can't go like you can't do serious editing and then losing like half an hour of your edits because it just restarted. That's why uh, thought, okay, let's go back to Intel and have a stable power. But the issue is like at the same time, Threadrippers came up, and they have like better single core performance, I believe. And the issue is that Mormon, yes. Oh, nice. For AI, yeah, Mormon. Yeah, so I guess Threadripper would be probably a good choice. I wasn't at this time. It wasn't like clear if how stable they are. That you hate AI, nice. Um, 97950. Yeah, that's close to what? What is this like? Uh, you have as much RAM as the storage. 32 threads. Yeah. The single thread performance is what is the bottleneck on this PC actually. There's like some if you go, oh yeah, what did I show here? Yeah, there you see here, at that. Ah, log in. That was my test. You see, yeah, this is the board when I try to. Oh, that's quite substantial. Anyways, the issue is when there are like sometimes, also with Altium, there are things that are running on a single core, and that's the bottleneck. You have to wait for a single core to be finished processing it. Okay, also enough of the meta. You're sending so much messages. Gigabyte. Yeah, 100 gigabytes, but they're like using as cache basically. So how Windows does it, uses any extra. It leaves like some unused, probably standby RAM, and then you have let's say my SSD isn't as fast as the RAM, and basically it uses the RAM as cache. That's why it's shown as it's used, but usually it would drop anything that's cached as soon as I need more than that. But I never saw any application use more than 64 gigs of RAM. I think the most was DaVinci Resolve, where I'm editing huge files. The files are, single file can be probably like 50 gigs or something. That's an exception. Usually they're around about 10 gigs. I want them all to be cached. That's why I liked to have so much RAM. But not even Resolve or Windows manages to cache the files. They have like they use proxies for that, to being able to edit faster. So actually, I believe 64 gigs of RAM is good enough. The 80 gigs AI model isn't shown in the process list for me, only in the RAM graph. What? RAM. I need a graphics card with 80 gigs. Yes, RAM disk. And that's basically that's RAM disk that you have included with Windows right now. It's using extra RAM for cache. And then if you have like a fast SSD, because I forgot to put on the heatsink on my SSD, that's why it's thermal throttled all the time. So yeah, and I can't reach it without taking off the huge heatsink, and then I need to repaste my CPU, and I don't want to do that. So I'm not dealing with the issues. I'm just using the RAM as cache right now. Yeah, I just missed that there was this heatsink. I think I have it here somewhere. I just found it when moving to this place. I found it in the box of my PC or my that's not great. So my SSD is running hot all the time. I thought, oh, I will buy a fast Intel SSD quality thing. Bought it, built it in, but forgot to put a heatsink on, and now it's throttled. Yeah, that's how you call. You can call me a throttle for this in German. I should have put it on this thing, this extension, this M.2 extension board, so I can air cool it here. All right, so let's talk about the PSU. We can basically go lower with the voltage here to not waste anything on heat. Then we have VDD, which is if we go one level higher. This is level 0. This is the little cores, and we have an array of 32 little cores, and that's basically the voltage is VDD MCU 0. That's level 0. Then we have output is VDD MCU 0 and VDD MCU 1, VDD MCU 1 IO. So let me explain what happens here, not on this board, this here. So we can run these cores the pool degree. Oh, you had like a RAID? Is Z-pool a RAID? Oh no, yeah, that's terrible. All right, yeah. So the cores, we can run them, the little ones, we can run them like at 3 volts, 2.8 volts is I think the lowest. And but the thing is, we can go 0.4 volts above VCC on the IOs. So if we run it at let's say 2.6 volts or something. Can I let me check if I can fix it. Need to open that without showing my documents. Sorry. Here we go. Okay. All right. Parameters. So we can't go the fastest. Yeah, they only tested to 60 megahertz, but no, that. But where is the voltage? All right, here we go. It runs at 2 volts. Let's say 2 volts. You can probably run it at 100 megahertz, but the I/O is VIO 3.3 plus 0.4. So whatever is connected over the bus from this MCU can go. If we run it at 2 volts to conserve some power, the SPI and so on can go at highest to 2.4 volts. The issue is right now that we have like this core needs to run at, let's say, 3 volts or something. How many micro? Yeah, 65,536. A substantial amount. So we need to, this MCU runs, let's say, at 3 volts or 3.3 volts. So the I/O needs to run at a different power. That's why we have level 1. We have, fortunately, I have split the VDD MCU1 I/O lines to be a different VDDA. It's a mix of that. You could run it from whatever. It's weird, but basically the I/O banks have a different power. So we could run the I/O of this MCU on a different power level. That's at most 0.4 to have basically a stable like threshold or whatever on the I/O digital I/Os, 0.4 volts above the VDD MCU 0. Unfortunately, we have the chip select lines, and the less fortunate thing on this MCU is PC 13, 14, 15 are internally powered from VDD MCU 1. So when we have chip select, if we use, let's say, we could do a pull up on MCU 0 and then pull it down with this one, then it works. But these three can only do 3 milliamps, because like this internal switch. It's a little bit weird because you can run it from VBAD. Wait. Oh no, I connected VBAD to that. I should have. Yeah, so in the end, I probably will run the whole MCU, like the little ones from 3 volts, this one from 3.3 volts. So it's within the threshold for the 0.4 volts, just to not have the headache with the internals of what's happening here. And there is also like the higher level. So we have level 2.
which is basically the controller next to the connector, which also has 16 parallel lines output. That has also another voltage level. So we could step up like from, let's say we could run core like level 0 at 2.6 volts, level 1 at 3 volts, and then 3.3 volts from there on, like outside the card. It's a little bit weird. Yeah, but how did I miss that? I should have connected, but VBAT is so strange. It should have an individual line in that case. Usually you can disconnect VBAT completely. Decent decoupling? What do you mean? What do you mean? Close? Close to you mean? Oh, close to the threshold level, to the max level. Yeah, I will probably like not go right to the 0.4 volts, whatever. They are basically the lowest level. So, and the current is coming. The pins are not driving; they're sinking the current, because we have the so the it's only that what would happen is basically switching of the LED will pull up ground at most, but there is like 2 ground planes beneath that, so I don't believe that would happen, because that's like that's anode, common anode LEDs, so we are only like pulling the current to ground here. These could even have like, we can drive it from 3.4 volts, and it would still work if this is because the forward voltage is 2.6 or whatever. Yeah, it's weird. Everything is weird. We will test it. We will see what happens. If it melts, it melts. Yeah, 3.6 V, but you will, if V LED is 3.6 V or 4 V, then that will never arrive unless the LED is broken, because you have the voltage drop from the forward voltage. It will always be below 4 volts here. Like I think the red LED, and then you have also like the current limiting, so you have like another voltage drop from here to here. I'm not an expert, just saying. All right. Yeah. Shall we try to? Oh yeah, there is another thing about the power. So I'm switching always to the wrong. That's the base. Yeah, cluster board. So just for noise reduction, that was my recommendation that I got. We combine 3, so 1 pin will be driven like at most will draw 0.4 amps, so 400 milliamps, and we combine 3 pins to 1 line and 1 power line. Yes, we are we are almost, yes, 786 megabytes of RAM should be enough for everyone. And Xbox 360? What? Really? And you forgot the 2048 of the 303s. Oh, I even used the one with the bigger RAM. Let me check. CH32V. Oh, that's crazy low. They're so old now. All right, so we have I think, wait, VO3, we have the 64K SRAM versions here. So we have from those, we have 248 plus, then we have the controllers on the top of the board, 128. Oh no, 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 no. Here times, what is it? 64K. It's probably not that substantial. 64K. Yeah, well, that's another 140 megabytes of RAM, SRAM on the row controllers. The row and column controllers here. This is the column controller, this is the row controller. SRAM. Hmm. All right. Yeah. So now the power. We combine DDR5 RAM. We combine 3 pins here at 400 milliamps, I believe. Let me check that again. Sorry if I need to switch off the screen because I didn't protect my... Yeah, here we go. Oh, you had a nap? I had 2 naps today already. How about that? ITT. Yeah, so I did a power calculation for a full blade, a quarter blade that used times 1 PCI Express. This is times 4 PCI Express. That uses, yeah, 1. We have 12. Wait a second, didn't I use 6? No. Oh, 4. Bye bye. Didn't I use 16? Let me check. Or did I really use... Oh, the blade interface, blade level 2. Where is it? Here, blade H. Blade 8. Oh no, it's 12. All right. More. What is with the power lines? What is? Yeah, I'm talking about the power lines right now. We have yeah, 12 times 400 milliamps here. 400, this is the calculation. So, and then we combine 3 of those, that's 1.2 amps per combined cluster of, but we see that's lower than that actually. So probably we get away with like 1 amp per. Oh yeah, maybe that's a thing. We can test it. We will order 2 boards at first and see how they behave. No, it's no, wait, it's more than that. if we calculate our max power like 3000 watts divided by 128 boards, that's 24 watts, but PCI Express is specified for more. I mean, this is now 64 pins, so that's probably at its limit. 1 ounce copper. Yeah. So that should be alright. I mean, if we use anything lower per pin than 1 amp, we should be alright. And with the spec here, I closed that one here, blade base. Here, I don't know how it will behave. We will check with the thermal camera. Oh, closing that document. No, not this one. Here we go. This is the LED. This is just the LED. The LED doesn't need to carry a lot of current. This is the LED line, and that is capable of doing 2.24 amps. That's a single, but we will drive it like, what was it? The calc is 300, no, 400 milliamps instead of 2. There's 1/4 of that, what it's capable of. And no, it's not a GPU of LEDs. And this one here, all right, this one 2.24, and we drive it at 1 amp. Yeah, that should be probably a little bit thicker. I have enough room for that. Maybe I will do it, just extend it around here. Diet logic GPU. No, I'm not doing that. The next thing is an analog PC. Cosine. Explain the sheet you had open. Yeah, the sheet is basically yeah, you look at that. You have even a cost calculation. So voltage, current, watt power, count per blade. That was the calculation for a whole blade, whatever. The cost 13, that was like 14 cent. That was 9,000 US dollars just for that, and 2 kilowatt of power just for the MCUs. And this is the LEDs. We running them at 1 milliamp per channel, which is 3 milliamps in total, and that is a total of 670 watts. What else do we have? Oh yeah, that's the controllers. They need also some power. That's 2000 controllers, but that's not like substantial if you compare it to the other one, the other ones. Then we have, of course, different designs. That was a full blade design that we weren't able to transmit to JVC because the server crashed. It was just too big. 10,000 components with whatever, we had 1 million vias and so on. It choked, the JVC server choked on that. That was the calculation. We used an times 16 PCI Express connector, so we had plenty of pins for VCC0. Then I split it to 1/4 of the things. We removed the column controller because it would only control like 8 row controllers, which isn't enough. It's quite a waste. So we had only like 2 levels on one board, and I used PCI Express times 1 connector on that with 8 lines. And now we have the semi-final design for now is half a blade. We have the current, that's 5.12 amps for the total of 512 MCUs. and that's actually not true because they draw less than 10 milliamps per MCU. We distribute it on 12 pins, which results in 0.426 amps on current per pin. Why do I care about that? Because like if you look at the PCI Express pins, I mean they are rated for 2 amps per pin, more or less. PCI Express doesn't have so many power lines and it still supports like 60 watts or whatever. But if you have like constantly driving the maximum power over that connector, you need to dissipate it correctly, and I'm not sure if I will be able to do that, and especially it's enclosed in this plastic, so you never get like good cooling of the pins directly. You need to cool them indirectly by the PCB that is mounted on, which has like another 128 connectors right now. So I don't want to drive it at the maximum power, like maximum current, and make them like glow red hot and desolder themselves. So that's why I try to limit it to below 1/2 of an amp. And that's what's happening here right now. And physically I couldn't fit the times 16 connector. That's the times 16 connector with 162 positions. I couldn't physically fit it in that confined space. That chat. Chat is listening. That's quite interesting details that I'm sharing here on my calculations. Yeah, that's about it. That's the yeah, especially because the female connectors are on the carrier board. Here we go. So that's the that's the sum of pins, power pins, and if you need like at least as many pins for the ground because the current has to like circulate, huh? We are not like it's going even like from ground to that. That's why I added. That's why I added the grounds are here in between. You see, this is like the signals. I put the grounds between the signals. And plenty of vias for it to distribute. So this is basically the power section here. I bunched it up here. So the lines, the signal lines are close to the connector, as close as possible. And if you look at the back plane, it's basically the same. They are staggered, so we have like signal ground, and on the other side of that you have basically the signal opposing the ground. So we have plenty of grounds here. It's more than the power lines. All right. So that's about it. Yeah, there are 2 more power lines here. So this is the power line for this MCU alone, which doesn't need like even this thick wire. On the other side, no, it's on the same side though. All right. Enjoying it, good. Well, there's so many features. Yeah, we have like the MCU 0. That triggers me. That's the power for these MCUs here. Which is better. They are better for different things. If you want like a little open design and you don't want to pay around about $2,000 per year per seat, then KiCad is the right choice for you. And if you're working professionally in a team, then and you want like to be conformant with whatever Altium, if you aren't paying yourself, yes, basically, yeah. I like many features of Altium, specifically the impedance matching. You need like, I mean, you can calculate that with the calculator, but it's not built in. It doesn't switch like the widths of the traces when you switch layers. And Altium does that basically for free. Then you can combine. I have like, look at that, underestimated features. Look how many grids I have defined. I have basically for these are the counts of grids that I have, which are basically doing different things. Like if I want to copy and organize these MCUs, I have a rough grid for each of those pieces here. Then I have a grid for this vertical. Yeah, I get paid. Terran, this is the new cluster. This is the grid for basically spacing the traces here correctly. Then I have another grid for spacing these correctly. I have a grid for spacing these lines correctly, so I have enough space in between for the grounds. I have being paid. What? Did you pay it? Yeah, anyways, this is and you have the polar grids. Then you have the thing. Oh yeah, one thing. Let's say you have like an array. You can manage that by using rooms and whatever. But if I want to move a specific, let's say I want to move this specific via further away or whatever, then I can find similar objects, and I can pick what's filtered. So I can use any, but then I can also say, okay, same x coordinate, okay, and then I use okay, and it basically selects all the vias. Where is it? Ah, did I lose it? No. Here, look at that. Altium has a manufacturer library, and I doing my every single via that is like on the same x coordinate will be selected, and I can move all at once. That's one thing. Or if I let's say I want to select that's the ground pad. Wait, let me check the components and not the pads. Let's say I want the MCU, and I have them organized in arrays, and I want to basically select the same MCU on each of the sub-assembly sub-rows. So let me filter that, find similar objects, and I can just filter by, this is basically level 1, this is level 2. So this MCU in this double row is number 5, and I want to select every 5 on each of the sub assemblies, and you see that those are selected. That's quite cool. So this is one of the best features, and there are plenty more, but there are so many features. You are overwhelmed for the first 2 months, and then you just get your favorite ones and basically concentrate on using those. Jealous? Oh no, it's not like you don't fight Altium as well. There are like, I mean, there's always limits that you will hit. I also hit the limits with Altium. But there are like some things that simplifies the work. You was productive, ITT? That's cool. What did you do? Always gonna be learning curve, Altium tutorials, and yeah, that's cool. You can always find it, and Also, you can even ask Gemini. Gemini has the solution outright the first time. Sometimes they have changed the stuff in the UI, so it's not 100% spot on, but you can just type, how do I blah blah blah, and then you find a video tutorial on that, or the manual entry for that, or so the documentation is quite good. First PCBs, yeah. We got the first Alcium, yeah, I mean, the first PCBs actually are these here, so we have like our test boards already. We have two versions of that. And this is basically, this is basically what you see on screen, but it's only like one part here. So this here is what you see in real life. Hibernation. All right, enough of that. Oh no, I wanted to stream until 7. We didn't do much work. I want to do some power supply research. We need to go down. Either we have, where's our, we got some data sheets. Wait, is this LCSC? No, this is not the right one. This is not the right data sheet. Let me check, sorry. Need to watch my face while I try to not dox myself. I have some sheets somewhere here. Yeah, we researched a few of those. No, that's the connectors. Where are the? No, it's might be the wrong data sheet. No, that's only the connectors. Sorry. Sorry. Yeah, I can show you also this one here. I'm looking for the right data sheet that we got for linear. This, no, that won't be enough. That won't be good enough. We don't have 600 amps of 12 volts. And we are not able to dissipate 12 kilowatts. We are only able to, I hope we are able to dissipate 3 kilowatts. Okay, so I think this is the ones that we researched. Either that, or we just get DC to DC converters. Oh, this is too pricey. Although, what was the current limit on that? What was the current limit on that? 3 amps. Yeah, no, that's too pricey. So if we do one ourselves, yeah, no. Almost doxing myself. No, we have here 12.8, 2 amps output, 1 megahertz. That was really cheap, I believe. Yeah, 3 cents. That's 3 cents, but also it's the cheap alternative, and I don't. We have 30 cents is this one. 24,003 amps output. Yeah, I think this is the one that we would be able. I think I used that one before. That's quite tiny. Wait, what did I use on my board before? Some of them I have even here, but 3 amps we need quite a chunky inductor maybe. Oh, we just starting to use it, and yeah, it works. For now, I have no experience whatsoever. So we just tested it last time. It's controlled. We can control it from PC, but Not for dissipation, for cleaning up the ripple. This can help if your line's getting too noisy. But hey, you won't be able to chop up 3 kilowatts without a bridge config, I guess. What is a bridge config? I'm trying to split it to individual chunks of like 2 amps. So, and that will be plenty. Or we will need like a bigger. What's the cheapest? Like let's take a look at the DC. I would like one that where you can control. Oh yeah, we could try Murata. These are expensive. I think. Wait, let me check. I was at Embedded World, and I think I got even power products overview. Yeah, Murata. Yes, you can. The DP100, you can set everything over. That's, I think it's even serial because there's like an open tool where you can use it. You can set it. There is like a browser tool. You can control it from the browser, so you most probably are able. Yeah, I have 2 brochures. I learned at the Embedded World, I learned to take only stuff with me that I'm interested in. Oh, there is one thing. Oh, peeps. You found the yellow wire, congratulations. I have, where is it? I don't know if this brochure is here. I found one thing that is so nice to use, like a testing equipment. No, I don't. I think it's still downstairs. Yeah, I will show it to you next time. It's basically pins that you can on a plate with magnets, and test pins that you can put like easily place, and everything is so smooth and nice. Everyone was impressed who tested those pins, and I got a brochure. I will probably purchase it. It's a bigger purchase because they're like, I think a set is $130, but it's totally worth it. I will tell you that. Yeah, it's damn it. Where is it? I want to share it because I was really impressed. Oh, you missed too much. Yeah, we can. You can maybe help finding a solution of converting a ton of 12 volts by using many power supplies, conversions in parallel. Okay, let me grab it. I think it's downstairs. I will be back in a second. All right. So, one. Wait a second. I need strong. This is the thing. PC Byte. It looks like it's a startup or whatever, like a maker who made it work. And I tell you that these are like they're working so smooth. It's like it's weightless. I'm really not trying to sell you stuff, but look at the setup. You have basically the test pins here like that. Yeah, you can basically move it freely in space. Yeah. Oh. 199, 100. Yeah, here that's the one I think. $150. I will probably get one of those because it's like it was so easy to move. Like it's weightless. You can just place the probe there and be good. Oh, there are some specialized probes for antenna stuff. Yeah, I just need anything. I just need anything that is like easy to handle. I mean, I got like the magnet clamps here from Ali, but that's not comparable. I mean, they're all right. I can probably use that with a probe. Yeah. And it's spring loaded, I believe. Like the tip is might be. I'm not sure. Yeah, I could use that instead. Like, yeah, but this is the AliExpress version. Yeah, so it's not as I mean, they're okay, but once you touch the other thing, demo version, yes, that was what was it, $1? Yeah. So I'm if you're ever on a fair where they're oh really, Masadi? Nice. Patronics. You know what? I just don't want to pull the influencer card. It's so it's such a bad karma. I'm collecting bad karma whenever quite often it's happened to me in the past when I received free stuff and I just didn't came to like reviewing it or whatever or giving them the proper shout out that they required or wanted or whatever expected. So I feel really bad about the responsibility to having to show something, and I don't want to collect bad karma. I just pay the stuff that I like. In this case, I want them not to like give it for free. I want to support them. If like you can do it, I mean it's all right. I don't judge anyone. I just feel bad when I receive free stuff, and then like either it puts pressure on myself morally or whatever, or I have like a bad karma because I don't review it or whatever, and then it lands in corner somewhere or whatever, because my attention span is so short. I move projects like socks. Yes, I can give them a shout out. I can pay it. So let's start with that. If they give me an affiliate link, I will totally buy it myself. I can put the affiliate link. I probably try to get an affiliate, but I don't care. If people ask, I will say if it's a good product, I like to support it. It's quite pricey though, so it's probably not for every hobbyist. But working with with boards with that detail, like it's so small, getting into those corners of the QF ends. This is one thing that I would need right now as we speak, because testing the SPI, here I have like 3 or 4 or 2 resistors where the SPI is set off, but I can't get to the chip select line. The chip select line just is exposed either on one of those pins, which are 0.4 millimeter pin pitch or 0.5 millimeter pin pitch, or on the QFN. So to test that, to see do I get like a reset of the CS line or whatever, it's so unhandy. I need to solder on a jumper wire, like a hair thin wire there, to be able to do that. Oh, we can do it. We have the new soldering iron. Yes. Yeah, no, you can't put. So basically, I could put. Initially I had like the first version even had test points at the end. Let me show you that for the SPI, but you can't put them in the production version because the test points are basically also changing the impedance or the communication. You get reflections and whatnot. So you want to avoid like extra copper for transmission lines or whatever. At least, yeah, like star configuration and so on. So that's the reason why I also, I mean, I have on this design, these are the programming pins, and I wanted some programming pins extra for if I don't like expose them on the carrier board or here, and I really want to have them as closely as possible. These are not used for anything else, so they can be, they're not really crucial, but the programming pins for the row controllers here, they are shared with the CS lines because I don't have enough pins. And in this case, that's like the most distance, and it's adding like extra copper, so there's like some capacitance. Probably not in the megahertz range, but everything extra basically adds like reflections, noises, and your square wave gets like smoother and smoother. So it's probably not relevant for like I think the most that we were able to run was with this MCUs was 32 megahertz, megabits. So it's 64 megahertz. Was it 64? Yeah, something like that. So the clock speed was 32 megahertz, and it was still clean because we made it very clear to not have like it's not a huge star configuration. In that case, everything is kept really short, like the extra lines that are going off here. And your square wave looks as a sine at 100 megahertz. Where? What project? What? Yeah, so that's basically it looks still nice at 32 megahertz, and yeah, I want to keep it that way, so not adding any extra copper. Same here, I put the test beds really close to those lines. Peckle, yeah. And here it's also quite close. I can't get closer than that because these are already 1 millimeter. It's quite. I need this distance so I can make a proper pogo pin probe. They're quite tiny if you look at the back of the board here. So I need to hit it with an CNC because I need to program them individually. Oh no. All right. We have, yeah. The power products. I had like 2 brochures that I took. Murata.
Where's it? Where did I put them? Here. Are the power products? Power products overview. Here we go. So what do we have? We have Murata. Boop boop boop. And is there a list? What is that? Yeah, they have some things non-isolated for non-isolated surface mount. These are isolated. Where is it? Power over Ethernet, but they are not controllable. You can, so if we do like things like that, $50 A out. They're up to 50 amps modules. No, that's not the right thing. Isolated gate driver. Board mount. Here, wait. PSUs. That's bad. Shipping promotion. All right, and a Recom. I didn't know them. They have also quite nice things. At least I saw interesting. There's a module. Okay, that's cute. That's just the chips. Other modules. Watts, power in watts. Let's see what they have. Here, 20 amps. Also, can you keep it down a little? Because that's really distracting. I'm hearing you all the time in my ear. Everything you say. Just try to reduce your output a little. Didn't all the fair stuff? Yeah, no, I didn't tell it everyone. Yeah, what is this? VC. Yeah, that's probably the right thing here. Look at that, 20 amps. RPL 20. What's the price on that? Recon RPL 20. Oh, okay. $13. So you pay for the 20 amps, huh? But it's all right. I mean, if we how many do we need? Oh, that's quite a lot. Unknown also is talking too much. Too much. It's like off topic and congesting my ear because I hear that all the time. You can, if you don't want like for it to be sent to TTS also. Also, if you don't want to everything to be read on TTS,
because I having that in my ear and I can concentrate. You can use the exclamation mark in front and a space, and it won't be read because that's filtered as a command. So you can just exclamation mark and you no not pitch, just use a pure exclamation mark, and then you can write whatever you want that won't be read to me. Don't play too much with the pitch, that breaks sometimes TTS completely. All right. So let's see. Yeah, people don't pay. I really don't want to put like. I mean, I'm a free to play guy, so I don't want to put a cost barrier specifically because people from different places at the world try to contribute here, and I don't want to miss messages. Not everyone has spare money. That's a DC to DC converter. Let's see. DigiKey. That's a Recon Power DC DC converter. Input is basically 12 volts. Output is basically what we need. So just buying a bunch of those, but it's quite pricey. $13 per pop. If we buy 100 of those, we pay $1,000. That's a lot. And no, it doesn't work. Oh, sorry. Just demod everyone and I kicks whoever. Yeah. Also, just try to limit yourself to something that's meaningful that you want to say to me. Sorry about that. It's just a little too much. I don't know. Maybe we should add a filter next time. So we will do a maintenance stream next time. We will use Johnny's latest libraries, and we will add a filter for people who don't like to be read on TTS. Oh, there is one thing. If you want to turn off your TTS completely, you can use just a language that's not existent. Basically, exclamation mark lang and then none or whatever. You can build those supplies for much less than $13. Yeah, Peter, I know. Can you do that? Can you build one for me and then I will just order it assembled? Wi-Fi and L plug, what? That's as expensive as, I mean, if I use, that's 20 amps. If I get like one module for $1 that does 2 amps, it's quite similar. Power BFLGA module. What is this data sheet? Oh yeah, they are, because sometimes I'm soldering and I miss everything that's happening in the chat. Alright, so how does that work? Oh, that's basically, so what they do is basically they put a simple, so what do we have? Typical 80% efficiency. Oof, that's hard. Typical application, what does it output here? Yeah, you still need like plenty of stuff out there. Voltage input, yeah, it's right in the center. Yeah. characteristics. The stream is 3 hours. It ends in about 15 minutes. I'm going to eat something. Efficiency in percent. V in is here. Output, yeah, 3.3 volts. From 12 to 3.3 volts, it's only like 80%, maybe 85% efficient. So it needs some cooling there. If you 15% of 2 kilowatts is what? Yeah, quota limits. 300 watts of heat dissipation from the DC to DC converters. Uh-oh. Yeah, it's not nice. Okay, let's try something else. So the recon thing is not that great. Let's try Murata then. Murata DC. Let's try TME. 1 watt. Yeah, that's not cutting it. We need 2000 of those then. No current, yeah. Nordic, you say? Just throw the modules at me, please. So this is like the modules like that. I would like just a bag of modules like that, and we can solder them somewhere and be good. Because yeah, we can also take these, but that's probably not enough current. Let me check if we can do Ausgangsspannung. So should I switch to English for you? No, you have to live with that. Sorry. I don't see a language setting. Oh, here. Let's do English then. Polski. Haha. Efficiency. We can just go and take the most efficient one, whatever. Output current. Okay, we want minus. It just consumes 3 amps and returns nothing. What does that mean? Negative voltage or what? Minus minus output current. Body dimensions. Insulating manufacturer case protection against overload, anti-over voltage. Oh yeah, I like those things. Switching frequency, output voltage. Let's say 3.3 volts. And variable. We need also variable. Is there like a output current? Filtering. How do I filter that? Greater than 2? No. Oh wait, application. Here. Greater than. Can I do greater than 2? That works! Greater equal to 2? Yes, that works as well. Cool. Alright, so that works. You can filter like that and we get 1. What? Oh, I'm at minus 3.3. Sorry. Where is the output voltage? You know what? Huh? Why is it still only one? It's a random. That doesn't work properly. Huh? What? What is it filtering right now? It's weird. The filter is broken. Oh, am I filtering a specific part number or something? It was weird right now. Hey, Yumbo. Okay, let's start again with 3.3 volts here, DC. It's the right one. Available in stock. There's only one product. Let's go Mauser. Mauser, you win, or DigiKey. No, not pro. Octopart. Yeah, we could do. We could do Octopart, but it's also US, so I don't care. In the end, I will just pay it. I will just use whatever, wherever I can get the cheapest ones. What is with AliExpress? We had like ages ago, we had like those little DC to DC modules. They're like perfections. They're like perfections. Let me like optimize for power, and look at that. Look at that. How much current do they? 2 amps. All right. Okay, that's 2 amps. But you can set the output here. 90 cent. How much is that? 10 pieces. That's 40 cents per pop. I want. Oh, boost converter. No, I don't want a buck converter. Step down converter like that. 10 pieces. 9. Yeah, that's expensive. These are trimmable. Something like that would be great, so I can just plug him in and be good. Three ads? What? Sorry about that. What about the efficiency? Yeah. So one thing about those, if I can put them on the outer side of the container, then 10 pieces. What? No, what? No, that's 1 piece. 3, yeah, 7. That's so expensive. DC. Well, yeah, it doesn't say. 50% works or not. It either works or not. 4 amps. Oh no, they are not high efficiency. Did they say high efficiency? Oh no, it's this stuff again. I don't use that. Okay, DC high efficiency 40 amps. Okay, so what do we have? 3.3 volts, okay? What is this? Three amps? No, that's not. How much is that one? What about just plugging in many of those here? That's 300 watts, so we need 20 of those. No, 10 of those is 3 kilowatts. Just place them around, but probably if that's at 200, yeah, we need 20 of those. It's like 20 amps. There's no way we can drive them. And then if they forward like 12 volt, it breaks our board. And there's also not a pin for output enable, is it? Up to 95%, people. Up to 95%. Shongik's cap? What is it? Hongix. No good. What is it like? Temperature like range is 60 degrees C. Caps. No good. Yes, I trust you with that. I look something that's really solid. That we could just mount, and that's actually I could even use like stuff like that. He said no. Yeah, this is not fast enough. AMS. Oh yeah, that's a classic thing. I have several of those here. They're quite pricey. 1 amp. Yeah, we need 600 of those. Yeah, we can take like good stuff there. I guess we won't get under. Either we do it ourselves, design it, and I like these modules though. What they are? No, this is not surface. It's not flat because we have like the pins on the bottom. If it was like completely flat like these here, you could place them all on just an heatsink, a big heatsink too. That one looks cool though. That's the small ones. It's flat if you send it. Yeah, what current rating is then the cap? Yeah, there's no way we'll use it like that. Alright. It's time, peeps. If you have something, maybe DigiKey, last resort. Let's go the American side. The caps I'm gonna use for the CH what? Driven back are surely not connected for right. You have a C832V2 driven buck converter. That's cool. DF robot? What's with DF robot? The power supply. Oh. Okay, let me do that. try US side. $5 for is that $5? What is the step down? Withstands load current with suitable heat dissipation and has over temperature overload protections. Okay, at least it's protected. Then you have the control here, but how do you cool it? If you have like the jumpers on the back, you can't solder it down. So you need to pull to cool it, like put something on top, or what's the deal? It's a little bit weird. Like I like something like the little DC modules, the ones that replace these LM whatever 78075. No, what's the TO package ones? Where are they? I showed them recently. So they are completely flat on the back, and you can put a heatsink on that. So we could just put like an array of those TO package DC converters on, like, mounted on a metal plate and dissipate the hot glue FN. Radioactive. Input voltage quite high. Okay, output parameters 0 to 3 amps. Yeah, so that's like heat dissipation not required. So up to 3 amps. Then you need $5 for 3 amps. Ah, that's tough. We can just clone this. I mean, this is basically, this is the same as taking, what chip did we take? Like taking this chip, TI chip here, for 30 cents and making it ourselves. Or this one here. Oh no, this is, yeah, unit price 17 cents. No, that's low power. Okay, that's not TI. But if we take like a TI chip, 3 amps output, okay, they're all 3.8. Yeah, fine, I do it myself. Yeah, that's basically it. We just put a bunch of those on one PCB and manufacture it, and then place it however we need it. Maybe even with the connector that we need for this power supply. Oh, phew. Jesus, this is so precious. Okay, wait. If we do four of those, oh, how do we transfer 600 watt from those connectors? How do we do it? This is crazy. How do we PCBOA is good. Okay, peeps. Huh? Mind the detection pins. Needs some shorting. Oh. Yeah. Okay, next time we will make a TTS mute button. What's the connector? What's the connector called? Sonic, do you know? With the sensing pin connector, because we need to figure that out as well. We need some sort maybe of Okay, so these are the, do we, oh, look at that. This is what we need. This is what we need. We need a module that converts it, but does it, is it capable of doing, what's the specs on that? Like, we need something chunkier. 9, you don't need that. Don't mix and match. What? Just go with the connectors. Here, Molex. $1. But what's the, wait, what? 15 weeks? Uh-oh. Where's the, downloads the datasheet? Come on. What's the rating on that? It's only the measurements. Molex power signal. Rating is 1% above operating current. Uh-oh. Current rating 9.2 per pin, power pin. And how many power pins do we have? What is ground? What is, they're like 6 times 9.2 amps. Yeah. Okay, let's 6 times 9.2 times 12. Yeah, 10%. 10%, that's 10% above the current rating. All right, but how do you do, yeah, how do you do 9 amps on a PCB from this confined space? How do you do, you need to put solder on the traces here. So we need actually to remove like the solder mask from the copper traces here. Yeah, I will do that in that case. I mean, we need only like 4 of those. What's the current rating for this? You say, I don't need that. Yeah, but doesn't say anything. Splits to 4. That's cool though, because we can have then more boards than if we can split it ourselves or cable to cable. Nah. All right. Yeah, that's just another stream that we have to do. All right, peeps. Thank you for watching today. It's 7 o'clock. I have an appointment. Sorry we didn't do much today. Margin is really low, yeah. But that's also like the rating, the maximum rating. We don't want to run it at the maximum rating though. Bye everyone, have a nice remaining Sunday today. Oh, I have still some booster. You too. If you find anything that is helpful of converting the 12 volts down to 3.3 volts in a safe and cheap manner, maybe I will even use some part of the embezzlement fund here. Embezzlement fund, we have 68,000 Colombian pesos and 69 nice Swedish kronas. You didn't miss anything. We're trying to discover how do we make the current go away. All right. I'm just stopping right now. Bye bye everyone. Have a nice evening.